Hello everybody, my name is Zachary Ireland and welcome to my 2021 Science Fair project on the theoretical solutions to the dangers of nuclear power. I first became interested in this topic after being issued a textbook at the beginning of my grade 11 chemistry class. I was assigned a reading, and within that reading was the story and the discoveries of Ernest Rutherford. I read about his discovery of the alpha, beta, and gamma particles, and how his model of the atom was later disproven by Niels Bohr. When the Rutherford model of the atom was first introduced, it was taken as fact. It was considered true. And the idea of disproving something that was already true, changing the truth, that concept is what makes science so exciting. Science is true until it isn't. After reading this, I dug deeper into Ernest Rutherford's work, specifically on the topic of radiation. I became very interested in radiation and wanted to find out more, so I decided to do a project on it in the 2021 Science Fair. I based my project around finding an element that has a high likelihood of absorbing neutron radiation. Out of all 118 elements, I chose 6 to test because they seemed the most promising. In order to perform these calculations, I used variables such as volume, density, mass, area, width, Avogadro's constant, and sigma. There were many other variables at play, but these were the main ones used to derive the amount of nuclei per unit volume and the amount of reactions being able to be sustained per second. I also use a concept called neutron cross-sectional area. This is best pictured if we can visualize our nucleus as a sphere. If we were to cut that sphere in half, our neutron cross-sectional area would be the area of that side of the sphere that is exposed. Unfortunately, I was not able to calculate neutron cross-sectional area on my own, so I got it from data tables on reliable websites and used it in my calculations. Throughout the process of analyzing data, doing our calculations, and determining which element is best suited for the absorption of neutron radiation, I have learned a lot. There are an infinite amount of elements and compounds that we could test and see how well they absorb this neutron radiation. Me testing these 6 elements is barely scratching the surface of a huge area of science that still needs to be done. Although small scale, this project is still important because it contributes to my education and deepens my interest in science and pushes me to get an education in the science and perhaps conduct this research on my own one day. This project may also spread awareness about the safety and dangers of nuclear radiation and how to be safe around radiation in general. For a more detailed analysis of my project, you can go to the How section of my project folder and click on my project report. There, I break down my entire process and explain all the variables at hand. I hope you enjoy my project.